Some missiles use straight wings without sweepback, with double wedge or biconvex sections. So do some supersonic aircraft. But as with subsonic and transonic flight, sweepback is very important in supersonic flight. Look again at the single point moving supersonically. The air is undisturbed everywhere ahead of the marked lines. But behind them, in the white area, the air is affected. Now suppose the point is in fact the wing route of this straight-winged supersonic aircraft. The air has no warning of the wing's approach. But what if we sweep the wing back until it lies within the white area? Now the air ahead is warned of the wing's approach. So, although the aircraft is flying at supersonic speed, the wing behaves as though it were subsonic. It can therefore have a subsonic section. Today, in fact, most supersonic aircraft are highly swept or deltas. These aircraft do in fact have very thin subsonic wing sections with high enough lift coefficients at low speeds to avoid serious stalling and landing troubles. Although some of them are so fast that they still need extra braking devices when landing. The higher the speed at which an aircraft is designed to fly, the more highly swept it must be, so that the leading edge remains inside the marked lines. But there are limits beyond which the aircraft becomes difficult to handle, both at low and at supersonic speeds. So the choice is between straight wings, usually short and of low aspect ratio for sufficient strength, or highly swept, or delta wings. What decides the plan form of a particular supersonic aircraft? It's a compromise between many factors, a very important one of which is supersonic drag. Take a delta planform such as this. Plot its drag against Mach number. The curve is like this. A swept planform with the same amount of sweep will give this rather similar curve, while a straight wing, giving a similar landing speed, will give this quite different curve. The straight wing gives less drag at the higher Mach numbers than these particular swept or delta planforms. It looks as if below about Mach 2, the advantage for low drag lies with the swept shape. Or with the delta. While above Mach 2, the straight wing planform seems at first sight to be better. But drag can be reduced still further above Mach 2 by increasing sweep still more, provided the low speed problems can somehow be overcome. Here's one possible solution for the future. Vertical takeoff. Shapes like these may well be the supersonic airliners of the future.